So for question number 25, we want to find the amplitude, period, phase shift, and vertical shift for the graph of the function y equals negative 5 sine of 2x minus pi over 4, all plus 3. So we want to find the general form of the sinusoidal functions, which would be y is equal to a sine of b x minus h all plus k. And in this case, our amplitude is determined by this capital A value. More specifically, the amplitude is always the absolute value of A. So in this case, our amplitude would be a positive 5. Okay, we want to rewrite our function to look a little bit more like our general form. So I can write y equals negative 5 sine of 2x minus pi over 4, all plus 3, and I want to factor out that 2 in the inside of the sine function. So I'm going to write y is equal to negative 5 sine of 2 times x minus pi over 8, all plus 3. And you can see that if I factor in back in that 2, I get with what I originally started with. Okay, so our period comes from this b part. More specifically, our period is equal to 2 pi over the absolute value of b. So in this case, our period is going to be 2 pi divided by 2, and we get our period to be pi. Our phase shift comes from that h value, and then in this case, it's going to be pi over 8. And then our vertical shift comes from our k value, which is going to be 3 in this instance. So for question number 26, a transform tangent function has vertical asymptotes at every odd integer and passes through the points 0, 1, and 0.5, negative 3. Find a possible formula of the form f of x is equal to a tangent b of x plus k. We can see what that graph of the formula we were trying to find. So I typically like to draw what a typical tangent function looks like. And it will have somewhat of this behavior, asymptotes at x equals pi over 2 and x equals negative pi over 2. It intersects the origin and it has the point pi over 4, 1. So if we look at the graph that we're trying to find the formula for, we see that our k value is shifted up by 1, right? Our k is a shift up by 1. More so, our a value is going to give us that vertical stretch, right? And we're stretching by a factor of 4, and not only that, our tangent function is flipped, so it's going to be a negative 4. And lastly, how do we find the b? Well, we know the formula, the period, is equal to pi over the absolute value of b for our tangent function. In this case, in that graph, we can see that it repeats. It goes from -1 to 1, and then it goes from 1 to 3. So it's repeating for a period of 2 units. So we have 2 is equal to pi over the absolute value of b. And then I can say 2 times the absolute value of b is equal to pi, or that the absolute value of b is equal to pi over 2. So b is pi over 2 in this case. Therefore, I can write my formula as f of x is equal to -4 tangent of pi over 2 times x plus 1 to represent that graph. For question number 27, we want to find the period for each of the following functions. For a, we want to do f of x is equal to 6 tangent of 1/8 x. So we know that the period is going to be, for our tangent function, pi over the absolute value of b. And in this case, our b is 1/8. So we would get pi over 1/8. and that simplifies down to just 8 pi. So the period in this case is just 8 pi. Now for part B, we want to find the period for y equals -3 cosecant of 2/3 x minus pi. And so we know our formula in this case is going to be 2 pi over the absolute value b, because the relationship between the cosecant function is equal to 1 over the sine function. And I can say that my period is 2 pi over 2/3, which just simplifies down to 6 pi over 2, or 3 pi. So the period for part B is 3 pi. For question number 28, we're going to simplify the expression, and remember to show each of our steps in clear order. Write your final answer in simplest terms using a single trigonometric function if possible. So for part A, we have tangent theta times cosecant theta. I know that my tangent theta function can be represented as sine theta over cosine theta. And my cosecant theta function is the same thing as 1 over sine theta. Now, I can do a little bit of simplification and simply cross out the sine thetas and write this as 1 over cosine theta. And we know that to be the same thing as secant theta. For part B, we have cosine of x plus sine of x, and all of that squared minus 2 cosine of x times sine of x. Okay, so let's first write what we are given. Okay, so I want to expand the cosine of x plus sine of x squared, and I can write this as cosine squared x plus 2 cosine of x times sine of x plus sine of x squared minus 2 cosine of x sine of x. And now I can see that there is a little simplification that can happen, and so I'm just left with cosine squared of x plus sine squared of x, and this is just 1. For part C, we have 1 minus cosine squared of x times 1 plus cotangent squared of x. I know that 1 minus cosine squared of x, that is the same thing as just sine squared of x, using our trig identities, times, and 1 plus cotangent squared of x is the same thing as cosecant squared of x. And cosecant squared of x can be written as 1 over sine squared of x. So I have sine squared of x times 1 over sine squared of x, which just gives me 1. For question number 29, we want to show that secant of negative x minus cosine of negative x is equal to sine of x times tangent of x. So let's start with the left-hand side. So I'm going to write left, and our left-hand side is secant of negative x minus cosine of negative x. And I know that cosine is an even function and secant is an even function. So I can write this as secant of x minus cosine of x. Okay, so the next thing I want to do is simplify our secant of x function in terms of cosine. We know that secant of x is the same thing as 1 over cosine of x minus cosine of x. And I want to combine these terms. So I can write this as 1 over cosine of x minus cosine squared of x divided by cosine of x. So now I can combine my fractions, and I get 1 minus cosine squared of x, all divided by cosine of x. 1 minus cosine squared of x is the same thing as sine squared of x over cosine of x. And then I can split this sine squared up as sine of x times sine of x divided by cosine of x. And we see that we get that this is the same thing as sine of x times tangent of x, which is what we wanted to show going from the left-hand side to the right-hand side. So let's go ahead and put a little check to show that we've completed that. For question number 30, we want to express tangent of t in terms of sine of t if pi over 2 is less than t is less than pi. Okay, so the first thing I want to write is that tangent of t is equal to sine of t over cosine of t. And if I want to express tangent of t in terms of sine of t, I want to be able to manipulate this cosine of t to get that in terms of our sine function. Now here's a little hint that our t is in between pi over 2 and pi, so we need to think about what quadrant we are in. We are working in quadrant number 2. For values of t in between pi and pi over 2, we're looking at quadrant 2. So one thing I've noticed is that sine squared of t plus cosine squared of t is equal to 1. Or I can write this as cosine squared of t is equal to 1 minus sine squared of t. And then I can take the square root, so I get cosine of t is equal to plus or minus the square root of 1 minus sine squared of t. And since we were working in quadrant 2, we know that in this instance, we are looking at the negative root. So I can simplify sine of t over cosine of t as sine of t divided by negative the square root of 1 minus sine squared of t as we are working in quadrant 2. So let's go ahead and put a check because we've completed this problem. Question number 31. A security camera is mounted on a pole 9 feet above ground level. What angle of depression should be used if the camera is directed at a spot 4 feet above the ground and 16 feet from the pole? Round to the nearest degree. So let's go ahead and draw this picture and add a little bit more information. So we know that we have this pole that's 9 feet. And we want to figure out the angle of depression, so this angle right here, given that this other pole is 4 feet, or spot is 4 feet above the ground, and we are 16 feet in distance from that spot to the pole. Okay, so maybe I can create another little triangle right here in the center of the picture, and I know that this angle theta with the angle of depression is going to be the same as this angle theta. Okay, I can add more to my triangle. I know that this adjacent side to this angle theta is 16, and this opposite side is going to be a height of 5 feet, right? Because 9 minus 4 is 5. So I'm essentially looking at tangent of theta is equal to 5 over 16, opposite over adjacent. So therefore, theta is equal to tangent inverse of 5 over 16. And we can plug that into our calculator, making sure that we're in degrees mode, and we get approximately 17.354 degrees, and we went to round to the nearest degree, so we can say that our answer is 17 degrees. So the angle of depression that should be used if the camera is directed to a spot 4 feet above the ground and 16 from the pole is 17 degrees. Question number 32. Find exact values in radians for each of the following. So part A, we are looking at cosine of cosine inverse of negative 1 over the square root of 2. So the first thing we want to do is examine the inside part, cosine inverse of negative 1 over the square root of 2. So where is our cosine inverse function defined? Well, the inverse of our cosine function is defined for quadrants 1 and quadrant 2. So essentially, we can ask ourselves by looking at this inside part, cosine inverse of negative 1 over the square root of 2 is equal to some angle, right? We are looking for an angle value, or I can write this as negative 1 over the square root of 2 is equal to cosine of theta. So we were looking for what angle spits out a negative 1 over the square root of 2 if I'm working with the cosine function, and specifically working in quadrants 1 and quadrants 2. Well, that's going to be 3 pi over 4, right? So theta in this case is going to be 3 pi over 4. So I can write this as cosine, and now we know all of this is equal to 3 pi over 4. Okay, so what is cosine of 3 pi over 4? Well, that just gives me negative 1 over the square root of 2. Now for part B, we're looking at sine inverse of sine of 4 pi over 3. So the first thing we're going to do is look at our unit circle to figure out what this inside part is. What is sine of 4 pi over 3? Well, we just get a negative square root of 3 over 2 once we look at our unit circle. And then we need to ask ourselves, okay, what is sine inverse of negative square root of 3 over 2? And more specifically, we need to ask ourselves, where is our inverse sine function defined for? So, or what quadrant it's defined for. So our inverse sine function is defined for quadrants 1 and quadrants 4. So we need to ask ourselves, what angle spits out negative square root of 3 over 2 when I'm working with the sine function in quadrants 1 and in quadrants 4? So I can say that sine inverse of negative square root of 3 over 2 is equal to some angle, or negative square root of 3 over 2 is equal to sine theta. And what does that theta have to be? More specifically, where is that theta in quadrants 1 and quadrants 3? Well, theta would have to be negative pi over 3. So at negative pi over 3, we get, if I plug that into my sine function, I get an output of negative square root of 3 over 2. So I can say that sine inverse of negative square root of 3 over 2 is negative pi over 3.
Okay, starting with 32C, we have cosine of arcsine of negative 1/2. So arcsine is just another way of saying like sine inverse. So we could rewrite this as cosine of sine inverse of negative 1/2. So next we need to figure out where on our unit circle our sine function will give us this value here, like what angle that is. So we know on our unit circle we have this point here, which gives us that x is root 3 over 2 and y is negative 1/2. And remember, our arc sine, usually it really only looks from values from like the right side of the y-axis, or quadrants 1 and 4. So from here, we're going to say that this point here is our y value, which is what sine is on the unit circle. So we know that this here is just going to equal whatever this angle is. And this angle happens to be, theta here is going to equal, it's going to be negative pi over 6. So from here, what we want to do is say, what is cosine at negative pi over 6? So cosine at negative pi over 6 is just our x-coordinate, which is that root 3 over 2. So we know all this here should simplify down to square root of 3 over 2. Okay, next we have 32D. We have sine inverse of tan of 3 pi over 4. So first we need to figure out what tan of 3 pi over 4 is. So let's draw our unit circle here. So 3 pi over 4, so this is going to get us to pi over 2, or 2 pi over 4, and then halfway between that right here. This is going to be, excuse me, 3 pi over 4. So at this point here, if we look at our unit circle, we'll know that this here, the point, is negative root 2 over 2, comma root 2 over 2. And then that tangent is going to be equal to your y value over your x. And that's because tangent, we can imagine, is sine over cosine, and sine is your y value, cosine is like your x value. So it's going to be this divided by this, which just gets us negative 1. So we just have sine inverse of negative 1. So what is the inverse of, or where does sine give us a negative 1? So if sine is our y coordinate, we know it's got to be down here, and the only spot that we have a negative 1 for y is right here. So we just need to know what this angle is. That angle is going to be negative pi over 2. Okay, 33a, we're going to simplify and give an exact value for each of the following, and we will not include any trigonometric or inverse trig functions in our answer, and we will not use a calculator with this question. So, excuse me, anytime we see one of these questions, generally it's a good approach to draw a triangle with it. So I'm just going to sketch out some triangle, and the sizes of it probably aren't going to be very accurate afterwards, but our approach is that we're going to, imagine we have some angle here, theta, and that the arc cosine of this angle, or that we're going to have arc cosine of 20 over 29 is going to give us this angle here. So from here, we say, okay, cosine is what? Cosine is adjacent over hypotenuse, which, if we look here, adjacent lines up with 20, our hypotenuse is 29. So you say, okay, this will be 20, this will be 29. So now we need to get the tangent of this angle. So tangent of theta is going to equal the opposite over the adjacent. So now what we need to figure out is this side here. And the way that we do that is by using Pythagorean theorem. So we're going to have 20 squared plus, I'm going to call it y, just for the time being, y squared equals 29 squared. So we know that y squared is equal 29 squared minus 20 squared. And then from here, I'm going to have to use a little bit of calculator work just to show what this is, but we're not really supposed to use a calculator, just to plug in this expression here. That's sort of what the question wants us to do. So from here we say, okay, y squared equals, and we'll have 29 squared, which is 841, minus 20 squared, which is 400. So y squared is going to equal 441. And now if we take the square root of 441, we get that y is going to equal 21. So this number here is going to equal 21. So if we go back to here, we know that tangent of this angle equals opposite over adjacent. Now we know that that is going to be 21 over 20, which that answers our question here. So we set up a triangle, and then we go through and use Pythagorean's theorem to solve for the other side of the triangle, and then evaluate our outermost function. Okay, next one. we're going to do a similar process. So we're going to draw some triangle. So sine is opposite over hypotenuse. So from here, if we say that this is what angle we're kind of thinking of, our opposite is going to be 3, and our hypotenuse is going to be x. So now we just need to figure out what is this side here, our adjacent side. So because this is our adjacent side, I'll call it A for this question. And notice it's perfectly fine to have an x here, even though it's some variable. We're kind of going to derive an answer in terms of x. So from here, we know that a squared plus 3 squared, which is 9, equals x squared. So a squared equals x squared minus 9. Then you take the square root of both sides, and we get that we have x squared minus 9. We're not really able to simplify at all from here, so we just say that this here equals square root x squared minus 9. So now we have to do the secant. So I sometimes have a hard time immediately knowing what like secant, cosecant, and cotangent is, so I think of them in terms of cosine, or in terms of sine, cosine, and tangent. So I know that secant is equal to 1 over cosine, and I know that cosine is adjacent over hypotenuse, which means that secant is hypotenuse over adjacent. So next, we just have to know what our hypotenuse and adjacent are. We know this is our hypotenuse, this is our adjacent. So our answer here is going to be x divided by square root x squared minus 9. Okay, 34. We're going to solve this equation over this given interval and include any reference angles or other angles to find the solution, and give your answer in terms of radians rounded to 2 decimal places. The first thing I'm going to do is move everything with x to one side and everything without x to the other side. So I'm going to subtract this to this side, then subtract this to this side. So what I do if I get that is 4.5 sine of x is going to equal negative 3. So from here, I'm going to divide by 4.5 on both sides and get that sine of x equals negative 3 over 4.5. So 4.5 is the same thing as 9 halves, or we could also enter this into our calculator. What we should see is that this is negative 2/3. So next we want to figure out what angle gets us this y-coordinate of negative 2/3. So we can imagine it might be something along these lines here. Then there's going to be this other angle right here that's also going to have the same y value. So notice these two here have the same y value. So if we use our calculator and type in that x equals sine inverse of negative 2/3, it's going to tell us that x is equal to negative 0.7297. But this isn't included in our interval. This is outside of it, so we need to do a little bit of work. So this angle here represents as if we started here and went down to this point. What we want is if we went a whole pi over and then added that much. So one of our answers is going to be x is equal to that pi amount to the opposite side plus this distance. And if we do this, x is going to equal 3.87. Then the other one, we can imagine if we went a whole circle around, so 2 pi, and then we subtracted that amount off of it. So x is going to equal 2 pi minus 0.7297, which will get us that x is equal to 5.55. So these are our two answers there. X equals 3.87 and x equals 5.55. Okay, 35. We're going to solve this equation here. So first thing I'm going to point out is that we have some term squared, and that same term not being squared. So anytime we see this, we should be thinking of moving it into more of a quadratic form, and then making a substitution to solve. So I'm going to start by moving the cosine and negative, and the plus 1 to the opposite side. So from here, I can make some sort of substitution. So if I say that u equals cosine of x, I can rewrite my equation like this, which is much easier to solve. So from here, we're going to go ahead and use our quadratic equation. So we get negative b, so 1, plus or minus the square root of b squared, so 1 minus 4a c over 2a, which is 4. So we have 1 plus or minus the square root of 1 plus 8 over 4 equals 1 plus or minus the square root of 9 over 4. So 1 plus or minus 3 over 4. So we're going to have two separate answers here. One is going to be that u is going to equal 1. And then our other answer is that u is going to equal negative 1/2. So from here, we're going to take this and plug it back in up here. So now we have that cosine of x equals 1 and negative 1/2. So now we just need to solve this. So when does cosine equal these two values here? So let's start with cosine of 1. So we know cosine is our x value, so that happens here. So this angle, x, is 0. Next, we need to figure out when is cosine negative 1/2. So that's your x coordinate. So that occurs maybe around here. Oh, no, excuse me, that's positive. That occurs here and here. So at these points, this is negative 1/2, comma, root 3 over 2. Down here, this is negative 1/2, comma, negative root 3 over 2. So these angles here, we just need to figure out what these angles are. So, and again, you could use your calculator from here, or if you just know the unit circle well enough, you can kind of go from there. So this angle here, we know that this amount is pi over 6 past pi over 2. So this is going to be 4 pi over 6, which 4 pi over 6 simplifies down to 2 pi over 3. Oops. So next we need to figure out this angle here. So this is pi, and we go pi over 3 past that. So we'd have pi, or 3 pi over 3, plus this amount, so that's going to be 4 pi over 3. So these two here, or these three here, are all of our answers, which lines up with these two angles here on our unit circle, or excuse me, these three angles on the unit circle. Okay, number 36. We're going to solve this equation on the interval from 0 to 2 pi. So we have tangent of theta equals negative 4.5. So there's not really anything that we can do besides just going ahead and plugging this into our calculator. So if we take the arctan of both sides of 4.5 equals x, we find that x should equal, or excuse me, not x, we're going to use theta. We get that theta should equal negative 1.352. The problem is that's not defined on our interval. So this angle here is maybe something kind of like this. So then the other spot that we're going to get this same result is this angle here. So we know that this much here is that same theta. So the way that we're going to calculate this is we're going to have one of them be, if imagine we started here on our unit circle, we went all the way around to pi, and we subtracted off this amount. So one of our answers, that theta is going to equal pi minus 1.352. And if we go ahead and plug this in, we should get that theta is going to equal 1.79. And then the other way that we're going to get to this is we're going to imagine if we went all the way around the unit circle and then backwards this much, which is going to be like as if we did 2 pi and then minus that number. So 2 pi minus 1.352. And if we do this, we should get that theta is going to equal 4.93. So these are our two answers here. We get theta equals 1.79 and 4.93. And again, excuse me. So whenever we found this angle here, the reason why the other angle that went with it was up here like this as opposed to something like here is because we wanted the same ratio of y over x. So it's going to happen a whole 180 degrees away from here, just like that. Okay, 37, we're going to find all the exact angles and radians that satisfy the equation. Write your answer in terms of k, where k is an integer. Show your work including any reference angles or other angles used to find the solution. So the first thing that we notice is that we have this 3 theta here, which is kind of a problem. So the way that we're going to get around this is we're going to make some sort of substitution. So my substitution is going to be that u equals 3 theta. So from here, I get that sine of u equals negative root 2 over 2. And again, the negative 1 over root 2 is the same thing as root 2 over 2. So from here, we just need to figure out when is sine of u equal to negative root 2 over 2. So we're going to get two different values here. Remember, sine is your y coordinate. So one of them is going to be right here. The other one is going to be right here. So now if we know our unit circle, we know that this here is going to be negative pi over 4, and that this here is going to be pi plus pi over 4. So we're going to get that u will equal, and we could go with negative pi over 4, or instead of that, we can imagine going all the way around the unit circle this way. So this would be pi over 4 here, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So here we know that u is going to equal 5 pi over 4 and 7 pi over 4. So now both these also have this like plus 2 pi k, because we can always just go around the whole circle k times, which is what that k is saying basically. So we get that u equals 5 pi over 4 plus 2 pi k and 7 pi over 4 plus 2 pi k. So next we just need to make our substitution that u equals 3 theta. So from here, to solve for theta, we just have to divide by 3. So theta is going to equal 5 pi over 12 plus 2 pi over 3k. And we're also going to have a second one, 7 pi over 12 plus 2 pi k over 3. And those are going to be our answers there. Okay, we're doing 38 here. So this is in section 10.10, rate of change functions. This is kind of getting a little bit into some more calculus stuff, which sounds scary, but I promise you, it's actually really easy. you just kind of got to like do a little practice, get used to it, and focus on making sure that you understand what's going on conceptually. So for starters, we have some function p in terms of t, which means that it's a function of time. So we're going to explain in practical terms the meaning of dp divided by dt. So what this here means is this is sort of the change in the population of the town each year, or sort of like the rate of the population change is sort of some other ways to think about it. So what we're going to put here is that just that dp divided by dt, or usually you'll hear dp dt, represents the change in population of the town each year. Okay, next one here. For several years in the 1930s and 1940s, dp dt was a negative number. What was happening to the population during this time? So if dp dt is the change in the population each year, if that's negative, then that means that our population is changing negatively, or it's decreasing. So what we're going to say about the population is that just that the population of the town was decreasing because the rate of change was negative. Okay, C, for a short while, dp dt was 0. What was happening to the population during this time? So if our rate of change is 0, nothing is changing, right? So what that means is that our population was just constant. It was not changing. It wasn't increasing. It wasn't decreasing, because the change in the town's population was 0. Okay, 39. We have the graph of a function y equals f of x is given. Identify regions where the rate of change dy over dx is positive, negative, or 0. If your answer is an interval, use interval notation. So another common way to think about your derivative or the rate of change, or dy over dx, is that it's like your slope. Except it's going to be really your slope at one specific point. So for example, if I was to look at this point here, I can see its slope is something kind of like that. So because this here, that's a positive slope, right? It's going upwards here. We say that dy over dx is positive. So now we just need to figure out this kind of region here. So if you imagine sort of like sectioning off everything here, we can see that everything to the left of -1, our slope is positive, which means that dy over dx is positive. And so the way that we're going to write this in interval notation is we're going to say from -infinity to -1. And then, is our slope positive at -1? Well, if we look here, our slope is just something maybe like that, just 0 slope. So it's not positive, which means that we're going to put parentheses here because we're not including that point. So, and then kind of skipping down ahead, we saw just kind of what we were just talking about, that whenever x equals -1, we get this sort of line here, this horizontal line, because our slope is 0, which means that dy over dx is 0. So, last one here, when is it negative? Well, if we just looked at, say, like this point here, you can see our slope is pointing downwards. It's negative. So that means that dy over dx is negative. So now we just need to write this in interval notation. Use parentheses -1 because, again, -1 is not included here. Whenever x is -1, dy dx is 0. So we use parentheses here. So we go from -1 to infinity. We use parentheses around that. So use the information from parts A and B to determine which of the following graphs could be the rate of change dy dx. So on this graph here, we're going to say that like dy dx is our x-axis, or excuse me, our y-axis, but we still have x along our x-axis. So it's kind of like our height on the graph represents our slope. So the further up we are on the graph, the higher our slope is. And likewise, the further negative we are on the graph, like the further down low, like somewhere down here, should expect a negative slope on our original graph. So the one thing that we can for sure look for is we know that our height, dy dx, is 0 whenever x is negative 1. So let's look for some that has this property. So a here, we can see that is 0, it's at 0 whenever x is negative 1. We can see, I think b is 0 at negative 1. It's a little hard to tell, the graph's kind of small. Same with c. D is not 0 whenever whenever x is negative 1, and same with e. So I'm going to immediately cross these ones out. So next, I'm going to look for, I know that whenever I'm to the left of this point, I should be positive. So if we look to the left of this, we're positive, so that one's good. If we look to the left of negative 1, we're negative. So this one here is out. And then if we look at C, we can see to the left of negative 1, we're on the positive height, or positive dy dx. So next we look to the right of x equals negative 1. So over here, we should expect it to be negative based on what we said here. So we notice this here is negative, so C is good. If we look at A, to the right of negative 1, we're positive again, which does not line up with what we were expecting. So A is out, which means that our answer is going to be C.